A key part of simple linear regression is assessing correlation. Symbol for that is lowercase r. We call it the coefficient of correlation, and it has a definition that you will likely be examined on. It's the strength of the association between two variables, typically x and y. Take note, there are no units associated with correlation, and correlation does not represent a percentage. Correlation spans the range from negative 1.0 to positive 1.0, with 0 in the middle, and we'll talk about the significance of these values in a moment. However, the sign doesn't really tell you anything other than the direction of the correlation. What I mean by that is if r has a negative value, then the slope of the regression line will be negative. If r has a positive correlation, then you will rise from right to left. But it doesn't refer to the quality of the correlation. Now, if you compute r to be positive or negative 1.0, you've probably made a mistake. That shouldn't happen. And if you get exactly 0, that shouldn't happen either. So what about the numbers in between? Now, the values I'm going to use are generally accepted values. They will change depending on the domain in which you're applying this technique. So, for general use, we have weak correlation, a weak positive correlation, usually from 0 to positive 0.5. We label mild correlation from 0.5 to 0.8, and again this is positive, and then strong correlation occurs for values between 0.8 and the unattainable 1.0. Of course, this is symmetrical across to the negative side. This would be a weak correlation to negative 0.50. This would be a mild negative correlation out to negative 0.80, and then we would have a strong negative in the last part of our interval. There we go. Now, what does this refer to really? So if we have, there's no correlation here in the middle, none, okay? Now, if we have strong correlation, we can see it usually graphically because the cluster of observations represented by the dots on the scatter plot are fairly tightly clustered around the line of best fit. If we were to make an ellipse around here, it would be almost cigar-shaped. Now, if we had a weak correlation, we'll use the other graph here for that, then the cluster of observations around it will be a much broader ellipse. So this is a weak or a mild correlation here, the positive nature. And over here, we would call this a strong negative. There we go. Now, there is an extension to this idea, and it does represent percentage, and that's called the coefficient of determination. I'm going to make a note here, coefficient of determination. And it is r squared. So for instance, if r was equal to negative 0.70, then r squared would be 0.49 or 49%. So there we have something different. The coefficient of determination is a percentage, and its definition, and you will likely be asked about this, is that it explains or tells you the percentage of variability in the dependent variable, usually y, that can be explained by the independent variable x. And so it makes for a useful assessment of the quality of your regression line. Let's make a note about that. Definition. This is the percentage, or the percent of variability in y explained by x. So you're going to want to commit that to memory. That makes for an excellent exam question. So there's a basic introduction to the correlation coefficient r, and by extension the coefficient of determination r squared, and the role they play in simple linear regression.